Good day, my dear students. We are continuing with our coordinate geometry. Our specific objective at the end of the lesson, the student should be able to find the angle between two intersecting lines and then apply linear graph in solving real-life problems. The angle between two intersecting lines. This, intersecting straight lines. We say given any straight line, the gradient of the line has been defined previously as the tangent of the angle which the line makes with the positive x-axis. You recall we said that you can equally take the tangent of the angle which the line makes with the positive x-axis if you are looking for the gradient of the line. Otherwise, you may decide to make y the subject of the formula in the system of the equation and take the quotient of x as the gradient. So we can intersect the two lines on the same plane to get this result. Theta 1 and 2 are the angles which the lines make with the positive x-axis, while theta 3 is the angle between the two intersecting lines. Having seen it, from the property of triangles, we believe we have already known that the sum of two interior angles will be equal to one exterior angle, which means that the sum of theta 1 and theta 2 will give, sum of theta 1 and theta 3 will give you theta 2. Hence, we define it in this way, and making theta 3 the subject of the formula, which is the angle between the two lines and which we are talking about, we shall get theta 3 to be equal to theta 2 minus theta 1. Then from compact trigonometry, we already know that the tangent of the angle is a measure of the gradient of the line. So to take the tangent of theta 3 means to take the tangent of the difference between theta 2 and 1. Therefore, tan theta 3 is equal to tan theta 2 minus theta 1. We are putting absolute value here to ensure that nothing is negative. The real meaning of absolute value is that negativity is not admitted. It's not permitted. It's not allowed. By formula, tan theta 2 minus theta 1 becomes tan theta 2 minus tan theta 1 all over 1 plus tan theta 2 tan theta 1. So what we are going to do is to write this down. In short, you have to write everything down, put everything down, and go through it one time and another in order to know how to do it. We shall use G to represent the tangent since it measures the gradient. So tan theta 2 becomes G2 and tan theta 1 becomes G1, for which we want to make only theta 3 the subject of the formula. We take the arc of the tangent of the resulting system in order to get our theta 3, which is the angle between the two lines. So this is the formula with which you can use to find the angle between two intersecting lines. And to find the angle means you must know the gradient of the respective lines in question. We take example. Example says, find the angle between the lines 2y plus 2x equal to 5 and y minus 3x equals 16. What do you need to do? I've already told you how to get the gradient of a line given the equation. In each case, make y the subject of the formula and take the coefficient of x, which in equation 1, we have made y the subject of the formula, only to see that, this your mouse is doing somehow, only to see that G1 is minus 1 and G2 is 3. Then we put the formula straight the way it was given. See the formula as is given. We are looking for theta 3, put in the values, G2 is 3, G1 is minus 1, put in the values, evaluate, and come down to see that theta 3 is equal to absolute value of arc tan minus 2, which is the absolute value of minus 63.4 degrees, giving us 63.4 degrees. But recall that once the angle between two lines is given like this, there is another angle between the two lines. That angle is going to be given as 180 degrees minus the angle given already. Because there are two possible angles that can be found between two intersecting lines. One, in short, two of them are going to be adjacent to each other. But take this. Assuming the two lines are not intersecting, but they are moving, we now recall that when two lines are moving in the same direction continuously, irrespective of distance, but never met anywhere, we say that the two lines are parallel to each other. Therefore, we need to know that the angle between two parallel lines is 0. Hence, from the formula we already know, tan theta 3 becomes tan 0 since the angle between them is 0 and the tangent of 0 is 0. If that is true, what do we do? 0 is equal to 0 over 1, equate it to g2 minus g1 over 1 plus g2 g1, and make a relationship between g2 and g1. By your cross multiplication, you get this. And after opening bracket, remember 0 multiplying anything is equal to 0. But 1 multiplying anything is equal to itself. That thing. At the end, we conclude that when two lines are parallel to each other, their gradients are equal. So the characterization of parallel lines is that they have the same gradient. Irrespective of the intercept on the y-axis, their gradient must be the same. So if there are 1,000 straight lines that are parallel to one another, G1 will be equal to G2, equal to G2, equal to, until you get to the end. We carry on. Having explained this, example will make it clearer. It says find the equation of the line parallel to y equal to 4x minus 9 and which passes through the points x equal to 3, y equal to minus 1. By solution, state the equation as it is given and make y the subject of the formula, which is already the way it is supposed to be, and discover that the gradient is 4. If the gradient of the first line given is 4, since they are parallel to each other, the gradient of the second line must also be 4. That's why we recorded here that G2 consequently is equal to 4, since they are parallel to each other. We state our equation. Remember the original formula we used the other day. This formula, we call it gradient 1-point formula. A is the gradient which has been represented by G1 and G2, each of them being equal to 4 because they are parallel. Then x1, y1 giving us 3 minus 1, putting the values in the equation. y1 is minus 1, look at it here. x1 is 3, look at it here. Then open all brackets, remember minus minus is plus. At the end, you collect terms as necessary and get that y is equal to 4x minus 13. The original equation read y is equal to 4x minus 9, but this one is reading y is equal to 4x minus 13, showing they have the same gradient, but they don't have the same vertical intercept. So each of them crossed y-axis at different points. Assuming the two lines are perpendicular to each other, it means that the angle of intersection between them is 90 degrees. Then what are we going to get at the end? We follow our formula and write that tan theta 3 will mean tan 90 degrees. And remember, tan 90 degrees is undefined, is infinity, which is mathematically represented as 1 over 0. Then equate 1 over 0 to the right-hand side of the system and make your cross multiplication in order to find the relationship between G1 and G2. By our cross multiplication, we get this, and 0 multiplying this will be equal to 0. We open brackets to get that 1 plus G1, G2 is equal to 0. Then, subtracting 1 from both sides has given us that the product of the gradients of the two lines that are perpendicular to each other must be minus 1. So when two lines are perpendicular to each other, the product of their gradients is equal to minus 1. Then make either of the two the subject of the formula if you are looking for one of them. So these are your solutions. So G1, G2 or G2, G1 is equal to minus 1. We move ahead. Example. It said find the equation of the line perpendicular to 2y is equal to 3x plus 7 and which passes through the point 5, 2. Recall, you have been given this. So by making y the subject of the formula, which I will want you to do, I want you student to make y the subject of the formula and take the coefficient of s, which is the gradient of the first line, you will get it 2 over 3. What is the consequence? The consequence is that the gradient of the second line is going to be negative inverse of the gradient of the first one, which is minus 1 multiplying 1 over the other one. It will now turn 3 over 2 into 2 over 3, but must carry a negative sign. Our initial points are x1, y1 being 5, 2. So we use our gradient 1 point formula and put in values to get our answer. y1 is 2, x1 is 5, our gradient is minus 2 over 3. So we multiply everywhere here by 3 to get this line, open bracket and connect terms as necessary, and end at 3y plus 2s equal to 16, which is the line, the equation of the line that is perpendicular to the given problem. Is there any way we can apply linear graph to real life situation? There are many ways of doing that, but we can choose just any one to make it clearer to you so that you understand what we mean. We say the linear graph can be applied in many areas of life. For example, a man may at the beginning of the year decide to be keeping the sum of 20,000 naira in a separate account so that at the end of every month, with the objective of paying off a particular bill at the end of the year. So the accumulation of the money can be represented and viewed from a linear graph, as will be seen very soon. The table of values. Since everything is written in thousands and there is no much space here to represent the thing in a table, we reduce it by multiplying by a multiplying factor. We say whatever you have here as money, multiply it by 1,000 naira. The months run from January down to December, period of 12 months. The amount per month is 20,000 naira, 20,000 naira. Then accumulation at the end of the month is what we are having here. So we call month X and we call the accumulation Y. What is going to be the amount at the end of January? It is 1 because the month January is represented by 1. Multiply 1 by 20, you get what? 20. In September, at the end of September, you are going to get, this is not 18 minus, it is just 18. September is the 9th month of the year. Use 9 to multiply 20,000 naira, you get 180,000 naira. That is the accumulation at the end of 9 months. Therefore, at the end of the year, which is in December, what do you think we are going to get? December is 12, the 12th month of the year. Use 12 to multiply 20,000 and you get 240,000 naira. That is what the man is going to get in the account if we are neglecting the interest that may be given to the man or some charges. What do we understand? We understand that the relationship is that the accumulation, remember I was multiplying by 20, will be given as y to be equal to 20x, meaning accumulation is equal to 20 times the number of the months. It can still equally be written as y to be equal to 20x plus 0. This 0 is the intercept, showing that the graph will pass through the origin. The origin is a point where both x and y are equal to 0, which reveals that the graph will pass through the origin. And the gradient of the graph is going to be 20,000 naira, which is the common difference. If we look at the system, you see it looks like arithmetic progression, increasing by 20,000 naira every month. Then the graph, I want you to plot it and see what is going to come out of it and how beautiful your work will be. STW, students to work. You are to use the table of values above as given to you and plot the graph of the relationship y is equal to 20x, where x is the number of the months and y is the accumulation at the end of the month. Remember, there are many more applications of this aspect of geometry in real life. So you are therefore challenged as a student to state the formula for calculating the distance from a point to a line. You are also to state the formula for calculating the area of a triangle, and then the formula for calculating the area of parallelogram. Here I do not mean length times width, I do not mean half base times height, I mean the formula for calculating the area of triangle and the area of parallelogram in relation to the coordinates of the vertices as is related to coordinate geometry. That's what I want you to do. Please copy everything down, do your work, check wherever you are not understanding very clearly, let us know. You have our Google Classroom, visit account or whatever. Thank you very much, my dear students. God bless you.